Beneath the serene beauty of the Pacific Northwest, something is happening. Deep under the waves, where the ocean floor plunges into darkness, a profound change may be underway. Imagine the very foundation of the Earth, a vast and colossal plate of rock beginning to tear apart. This is not the opening scene of a disaster film. This is the conclusion of new, meticulous scientific research. Scientists studying the complex geology beneath Vancouver Island have found evidence of a potential tear. This rupture is located in the Cascadia Subduction Zone, a region long known for its capacity to produce powerful earthquakes. The discovery raises questions that ripple from the seafloor to the cities above. The research, led by geologists using a wealth of data, points to a gap. So, what do you think? This seems to be happening in conjunction with axial seamount, though scientists say these are two distinct events. I would love to hear from you in the comments below. To truly grasp what is happening, we must journey deep into the Earth. Our planet's surface is not a single, solid shell. It is a mosaic of enormous, rigid pieces called tectonic plates. These plates are in constant, incredibly slow motion, floating on the semi-molten mantle below. Where these giants meet, the planet's most dramatic events unfold. A subduction zone is one such meeting place. It is where two plates collide. One, typically a denser oceanic plate, bends and slides beneath a lighter continental plate. This process is one of the fundamental engines of our living planet, shaping continents and creating the very land we inhabit. The Cascadia Subduction Zone is a prime example of this titanic process. Here, the oceanic Juan de Fuca plate is slowly diving eastward beneath the North American plate. This slow-motion collision is responsible for the magnificent volcanic peaks of the Cascade Range, including Mount St. Helens and Mount Rainier. It is also the source of immense geological stress. As the Juan de Fuca plate scrapes and grinds its way downward, the overlying North American plate gets stuck, compressing and deforming like a giant spring. For centuries, this stored energy builds silently. This process is not smooth. It is a cycle of tension and release, and the release can be catastrophic. The Great Earthquake of 1700 is a stark reminder. Geological evidence and an orphan tsunami recorded in Japan tell the story of a massive rupture along the entire Cascadia Fault. The ground shook violently, and a huge wave swept across the Pacific. Scientists watch these zones with immense focus, using instruments to detect the faintest tremors and the slightest movements of the crust. But what happens when the descending plate itself begins to fail? Under immense strain, it can develop a weakness, a fracture, or even a complete tear. So, how did scientists uncover this hidden drama miles beneath the Earth's surface? The discovery wasn't a single eureka. It was many lines of evidence adding up. Researchers used a suite of advanced technologies to image below the crust. High-resolution bathymetry, sonar maps of the seafloor. Seismic tomography uses waves from distant earthquakes to make CT-like images. Those images show hotter or colder, denser or weaker zones. The data converged on an anomaly near the northern end of the Cascadia Subduction Zone, just beneath Vancouver Island. The Juan de Fuca plate looks incomplete beneath Vancouver Island. Seismic images showed a gap, hot, less rigid material where a cold slab should be. That gap, the slab window, is key evidence for a tear. Further support came from GPS tracking millimeter-scale land movements and patterns of small, localized earthquakes, hinting at deep stress anomalies. New papers present compelling maps and cross-sections, showing the inferred tear and how it might influence regional geology. The tear corresponds with unusual volcanism and subtle deformation patterns. The conclusion is stark. The tectonic plate appears fundamentally broken, but the scientific method demands caution and verification. These findings are new, interpretations are challenging, and other teams are rechecking with fresh models. A tear could explain several previously puzzling northern Cascadia features. Science builds consensus. More data, more review. We mustn't jump to conclusions, but we must listen closely to what the Earth is telling us. The area in question is part of the infamous Cascadia subduction zone. This is a massive fault line stretching from Northern California to British Columbia. History tells us this zone is not dormant. It is merely sleeping. It has unleashed colossal earthquakes in the past. The last, in the year 1700, when a tectonic plate begins to tear, the intricate balance of stress and strain across the entire system can shift. This could potentially alter where and how seismic energy is stored and released. It could change the location of future earthquakes and modify their intensity. The critical point is not one of alarm, but of attention. Scientists have identified an anomaly. Now they must decipher what it means. The puzzle of this tearing plate is just beginning to be assembled. The initial findings provide a new, startling picture, but the full image is not yet clear. Researchers must ask if this tear is recent, a long-standing feature, or newly visible thanks to advanced technology. Next steps: detailed surveys, sophisticated models, and a collaborative global effort. The discovery is a testament to human curiosity and our relentless pursuit of knowledge. But it is also a reminder that the ground beneath our feet is not as solid as it seems. A tear implies a redistribution of stress, with potential implications for cities like Seattle, Vancouver, and Portland. It could also focus heat flow, creating magma over geologic timescales and shifting volcanic patterns in unexpected places. While not an immediate threat, it's a significant factor in long-term landscape evolution and in how we plan for earthquakes and secondary hazards. This is not doom. It is a prompt to reevaluate assumptions and improve preparedness. In the face of such a profound discovery, what is the scientific community's next move? Gather more data with greater precision and focus. Scientists are deploying more instruments to create a denser monitoring network. This includes placing state-of-the-art seismometers on the ocean floor directly above the suspected tear. They can listen for the faintest deep earth tremors and provide a much clearer picture of the slab structure. It is like moving from a blurry photograph to a high-definition image, revealing details that were previously invisible. New marine surveys will map the seafloor and subsea floor structures with unprecedented resolution. They'll measure heat flow, looking for warm spots that could indicate rising mantle material. On land, high-precision GPS networks will expand, tracking subtle bulging or sinking of the ground. Every millimeter tells a part of the story. Sophisticated computer models simulate plate tearing physics and test scenarios. What happens if the tear grows? How is stress transferred? Could it trigger smaller quakes? These tools turn raw data into actionable knowledge and improved hazard assessments. Universities, the U.S. Geological Survey, the Geological Survey of Canada, and international partners are sharing data, re-examining records, and building a robust understanding. The response to the Vancouver Island anomaly exemplifies collective discovery in service of public safety. The Earth is a dynamic planet, and its movements are beyond human control. We cannot stop an earthquake from happening. However, we are not powerless. We can prepare and build resilient communities. The first step is ensuring our built environment is strong, enforcing and updating building codes, and investing in retrofits for schools, hospitals, bridges, and essential utility networks. A building that stands is a life that is saved. Every community and household needs a clear, practiced emergency plan. This starts with education, drop, cover, hold on. For coastal areas, no evacuation routes and assembly points. Planning is the antidote to panic. Practice makes the plan work. Every home needs a kit with water, non-perishable food, first aid, and essentials for several days. After a major quake, help can take time. Being ready reduces strain on first responders. Self-reliance strengthens the entire community. Clear communication is essential. From scientists to officials to citizens, action turns knowledge into lives saved. Even with our most advanced technology, the Earth holds its secrets close. The deep interior remains a frontier of discovery. The potential tear beneath Vancouver Island is a major feature newly in view. Evidence is compelling, yet questions linger. The full story is an unwritten chapter in Earth's history. It will take years, perhaps decades of patient research. One key mystery is the tear's history and future. Is it new and growing, or an ancient scar? If growing, it could be changing the stress field now. If old, the system may have adjusted. Scientists will read the geological record to reconstruct the deep past. Another question, its influence on the big one. Severity, initiation point, timing, or barrier effects. Modeling this interplay is hard. Answers require new data and breakthroughs in rock mechanics. A tear could open pathways for mantle heat, but links to eruptions and timelines remain uncertain. The mystery reminds us how much we still have to learn. This story of geology and tectonics is not just about rocks and forces. It is profoundly human. For millennia, people have lived along this dynamic coast. Indigenous peoples hold deep knowledge of land and sea. Oral histories include accounts of past earthquakes and tsunamis, stories of shaking and retreating seas, aligning with geological evidence of the 1700 Cascadia event. This ancestral knowledge offers a human-scale view of deep time. Today, the coastline is a vibrant tapestry of communities. Fishermen, loggers, city dwellers, scientists. This discovery touches lives and futures here. It prompts conversations at dinner tables, in community halls, and in city councils. It builds a shared responsibility to prepare. Collaboration turns complex science into practical guidance. Scientists gain local insight. Communities gain actionable information. This partnership, science and society, is our greatest strength in building a safer future. The discovery of a potential tear beneath the Pacific Northwest reminds us our planet is always in motion. It adds a compelling chapter to Cascadia's story. This is not a cause for alarm, but a call for calm, deliberate action. Science reveals the hidden workings of our world. Evidence reshapes understanding. A clue is found, a hypothesis is formed, and rigorous testing begins. For those in active regions, the path is clear. Stay informed via USGS, universities, and local emergency managers. Share verified safety information with family, friends, and neighbors. Translate knowledge into preparedness. safer homes, practice plans, stronger networks. Cities update codes, strengthen infrastructure, refine evacuations. The future is not fixed. It is a path we build together. Ready to dive deeper into the matrix? Watch the next video here to see just how deep the rabbit hole goes. We can learn, innovate, and prepare. Scientists will watch, measure, and understand. Communities will strengthen foundations and plans. That is the real power here.